The session is called Climate Justice, the Data Science Perspective. And the organizer of the session is Yuji Tian from Temple University. And unfortunately, the first speaker in the session, Mark Tedesco from Columbia University, has just got COVID, so he cannot attend and participate. So we'll go to the second speaker, Lelia Marie Hampton, who is from Massachusetts Institute of Technology and who will talk about opportunities for machine learning in climate justice. Thank you very much, Leila, and the floor is yours. Thank you.
Awesome. Thank you so much for inviting me to this. This is an amazing just overall conference and workshop. So I really appreciate being able to attend. Let me just try and share my screen.
Yep.
Okay, awesome. Okay, awesome. So yeah, as stated, I'm Leila. I'm a third-year PhD student in electrical engineering and computer science at MIT. I work at the intersection of causal inference and social good, including on issues of climate and environmental justice, especially for policy issues. And yeah, and so today I'm going to talk about some opportunities for machine learning for climate justice for people who might be new to the area and kind of want to figure out their way around. And so yeah, and so let's
I'm sorry, it's still showing loading. I've seen your slides before, but now I see only loading.
It seems you are showing
maybe
the
exit
Safari.
full screen.
Yeah, I don't know, sorry, sometimes Google Docs gets a little bit weird. Okay, let me try again. Okay.
Yeah. See now.
Okay, now it's
No.
Maybe don't do full screen, you know.
Okay. Yeah, you're right. Let's
because yeah.
Okay, that works.
Oh.
Okay.
Yeah.
So does this work?
Sorry, if you have multiple monitors, what is happening is that you are projecting the slide in another monitor. So probably when you share a screen, you should choose the other monitor if you are using multiple monitors. But anyway, you showing this slide would also work.
It's okay. I guess you just don't need to pull full screen. And then it's up to you.
Okay, that makes sense. Sorry, let me try one more time.
Okay.
Work.
Yeah, it works. It works.
Okay,
it
awesome.
Works.
No, okay.
Thank you very much. Thank you.
Okay, cool. Okay, so getting into what climate justice is, so climate justice is a lot broader than we could talk about in 15 to 25 minutes, but just to start, it's very important ongoing issue in the 21st century. And even though a lot of affluent people and nations are actually producing most of the anthropogenic causes for global climate change, marginalized people, especially in underdeveloped nations, are bearing the heaviest burden of climate change. And so climate change is both an ideology and a movement that works to ensure the benefits and burdens of climate change are shared equitably across groups. And so the UN has, through their UN Council on Climate Justice, come up with the 6 pillars of climate justice with various stakeholders and rights holders. And so some of those are social, well, actually the 6 pillars are social, racial, and environmental justice, climate education and engagement, indigenous climate action, just transition, community resilience and adaptation, and natural climate solutions. And we'll talk about some of these as we go through the talk. And so there's a question about, you know, why machine learning or why data science or why deep learning? And so the truth is that there's a large amount of data in the 21st century, and we have more computational power than we've ever had. We can compute things that were unimaginable, like, you know, half a century ago. And also the 2010s ended up ushering in deep learning as we know it. And these things actually help us to leverage crucial information from data, providing us with extremely highly accurate linear or nonlinear estimations that reflect high performance on specified tasks. And this looks different ways. It looks like predictions and unsupervised learning, such as clustering. It also looks like causal inference. And so now we can actually answer a lot of social questions through this new mechanism. And so the goals for climate justice can actually be related back to the United Nations Sustainable Development Goals, such as reducing inequality or empowering women and things of this nature. And so one of them that is most prevalent to climate justice is SDG 13, which calls us to take urgent action to combat climate change and its impacts. And so I'm going to talk about some ways that we can actually address these SDG targets for SDG 13. And a lot of them are actually pretty related. So even though something might be listed under one target, it might actually help with multiple targets. So let's get into it. So for target 1, the goal is to strengthen resilience and adaptive capacity to climate-related hazards and natural disasters in all countries. And so an ongoing climate justice issue is that underdeveloped countries are experiencing and will continue to experience harsher impacts from climate-related hazards and natural disasters. And this also threatens food and water security, global health, and economic development. So for a lot of these countries who have not had the opportunity to develop economically in the same way that the global north has, they are now also being hindered from developing economically from climate issues, such as, for instance, like illegal deforestation or illegal fishing or natural disasters that destroy businesses and infrastructure and so on and so forth. So some machine learning interventions here could be, for example, using satellite imagery to detect any changes that can indicate the onset of a natural disaster. So things such as landslides or earthquakes, and helping to monitor or even have prevention responses to it. And this helps, again, with resilience and adaptive capacity by helping people to be able to do policy and planning before things happen and help them maybe help people evacuate and things of that nature. And so another thing, and also it helps with international help as well from like the UN and other places that tend to help with this type of stuff. Another thing that could help is seismic data to predict earthquakes and their magnitudes, using building data to assess earthquake resilience, and social media data to help locate survivors of natural disasters, as well as precipitation prediction. For instance, like rainfall is very important for hurricane seasons, and trying to figure out the severity of hurricanes. So these are some things that we can kind of do to kind of look at strengthening resilience and adaptive capacity. And even more so, large-scale data from across the globe could actually provide further insight into comparisons for climate-related hazards and natural disasters, which is relevant to international governance bodies. In other words, we can actually compare differences in strengthening in like resilience and adaptive capacity between countries so that we can kind of figure out the interventions that are necessary from the perspective of, for instance, the IPC, the UN, et cetera, ITU, and so on and so forth, so that we can allocate funding and on the ground help as needed. So for target 2 of SDG 13, the goal is to integrate climate change measures into national policies, strategies, and planning. And so climate change planning includes the mitigation of future climate change, primarily by reducing greenhouse gas emissions, adaptation to existing and projected environmental changes, and disaster risk reduction measures. And climate change informed planning must balance multiple and sometimes competing considerations, which actually makes it pretty difficult. And so one thing that we could do is leverage information from our data via machine learning, deep learning, or data science to actually help address unanswered or ongoing questions in climate justice to inform local and global policy. And so some potential machine learning interventions are disaster prediction and risk assessments to actually identify the most vulnerable, for instance, to earthquakes, tsunamis, hurricanes, and wildfires, which are ongoing issues all over the world, really, in the US, but also in the global South as well. And it's displacing people, and it's causing economic ruin, it's causing social ruin, it's causing climate migrants and all these other things. So yeah, and so damage assessment and monitoring from social media, satellite imagery, and crowdsourcing are also very important. So making sure that we can kind of understand the damage after it happens, so that we can, again, allocate funding and resources and international help and whatnot to be able to help people, help survivors and things of that nature. And so we, in the same vein, you can also use that for post-disaster coordination and response, using similar data, including social media data and crowdsourcing, to just kind of figure out where are the survivors, and where do emergency services need to be allocated in terms of fire departments and emergency medical services. And so for target 13, the goal is to improve education, awareness raising, and human and institutional capacity on climate change mitigation, adaptation, impact reduction, and early warning. And so as far as education and awareness raising, one could take the computational science, social science perspective and say, I'll look at some social media data so that we can kind of understand awareness of climate change impacts in various regions around the world, because then that might be useful to figure out where more education might be needed and where more awareness might need to be raised. The really important one is also helping enhance human and institutional capacity on climate change. And so one direction people could take is participatory research with local and national governments in underdeveloped countries and indigenous organizations by asking what they need instead of inserting ourselves with the Western savior complex, because a lot of times it's easy to say, oh, I think they'll need this, or I think they want this, or I want to do this. But it's even more important to figure out what people actually need and want for their own institutional capacities. And not try and force that on somebody. And so, for example, a government might want an early warning system for natural disasters, or they might want an assessment of areas that may be the most likely to be impacted in order to allocate funds. For instance, where's the most likely place to be impacted by this earthquake? Where's the most likely place to be impacted by this hurricane? Where's the most likely place to be harmed by this? And so this would augment their existing capacities, but not necessarily replace it. So it's important to understand the role of the interventions in machine learning and understanding that it's not the end all be all, but it's one tool to help. And so this is target A, which means that like the first 3 targets were actually originally implemented by the UN for the Sustainable Development Goals, but then they added 2 more after that. And so target A is dealing with implementing the commitment undertaken by developed country parties to the United Nations Framework Convention on Climate Change to a goal of mobilizing jointly 100 billion annually by 2020. And so the machine learning intervention here is kind of more, it's like not as critical, but it's interesting in terms of a direction. So for instance, you can look at machine learning for climate finance. And that's actually a direction that's currently making headway in terms of research in a lot of business schools. And it could be a nice area to provide some insights. And so for that, the question could be, what are the best uses of money based on available data? We don't really want to spend money where it won't help us achieve our climate goals. So then maybe we can use some of the existing data in the world to understand, does this actually help us achieve our goals, or is it something that just sounds nice? Causal inference could also be important here, which is used a lot in economic tools and increasingly used in machine learning. So we could ask, what are the causal effects of policies on certain outcomes? Do these policies actually help us achieve our outcomes if we spend money this way? Another thing that we could do is, for instance, like Monte Carlo simulations. So what happens under each scenario? So testing like a lot of scenarios and maybe trying to find out like, what are the top K best scenarios? if we spend money certain ways and stuff like that. And so those are just some ways that like potentially could be used to kind of understand like the way that we can approach the financial situation in terms of allocating funding for climate justice issues. And so target B of SDG 13 is to promote mechanisms for raising capacity for effective climate change related planning and management in the least developed countries and small island developing states, including focusing on women, youth, and local and marginalized communities. And so there are two areas of importance here that I wanted to mark, which is one is environmental degradation. And so droughts will actually impact agriculture, and they're currently impacting agriculture. And there's a lot of illegal deforestation and illegal fishing that's harming land and water. And so all of this is especially detrimental to indigenous people globally and in underdeveloped nations. We're already seeing this in South and Central America. And so can we monitor these things for government so that they can plan and manage these things? And so there's already some open source data here. For agriculture, people are using aerial imagery from drones, or they're also using like satellite imagery for illegal deforestation, also the same thing with satellite imagery. But people are also making, for some of these things, for instance, for illegal fishing, making geotag data sets to kind of figure out where people are illegally fishing. And so that could be a useful direction to kind of help people in terms of ensuring to track environmental degradation. Yeah, and so another direction that is important to go in is health disparities. So climate change is causing issues with air quality, water quality, and so many other things that impact human health. And even more so, climate change will continue to lead to pandemics. We've already seen some of that in terms of COVID-19. And so these health challenges will not be borne equally among groups. And so data science can play an important role in planning and management for pandemics to ensure that vulnerable groups receive the necessary resources from governments and other organizations. Not to mention that climate epidemiology is a growing field, and they do need more people, and data-driven insights could be extremely important to extracting crucial information from the data. And so I do want to specify that like working on climate justice is a high stakes setting. All of this is extremely important and high stakes for the most vulnerable, which is why we want to work on it in the first place. And so it's very vital to understand the limitations of our data and methods and adequately explain these limitations to stakeholders. If you're informing policymakers, it's important to remember that we can't pretend like machine learning is just a god and it's the end all be all. It's one tool that we have that we want to use. And so it's also important to consider the real world. So we make a lot of assumptions in our modeling, but it's important to understand that we have heavy tails, we have uncertainty, like unknown unknowns and known unknowns. And then we also have the tension between predictive versus causal estimates. And these are just a few things. We also have outliers and we have dynamic systems. And so a model, if it's static, it might not account for a dynamic system and all these other things. So it's important to just understand the limitations of our data and be able to communicate that to stakeholders as we're trying to use data science or machine learning or deep learning to inform climate justice issues. And it's also important to understand that this would be one source of information, but it would not necessarily be the only source of information. And the most important thing is to reduce anthropogenic causes of climate change. Machine learning does not necessarily do this. However, it might hopefully further inform and incentivize policymakers to address these issues. And here are some pitfalls to avoid, hopefully, which are generating carbon. So some approaches to machine learning for climate currently use very high dimensional data. So for instance, satellite imagery could be, it's basically just a huge tensor. It's like you could have like 240 by 240 or 320 by 320, and that's not even including the channels. So it's 3-dimensional. And then usually satellite images, like for instance, Landsat has 13 channels. Satellite images usually have a lot of channels. It's not just red, green, or blue. And so this is just very high dimensional data, which means it takes longer to compute naturally. And so also the neural networks we use are extremely large at this point, and they have a lot of parameters, they have a lot of neurons. And so computing high dimensional data with large neural networks takes huge computational capacity and leads to a lot of high carbon output. And this is actually antithetical to what we want here. We can't approach climate issues by generating more carbon. And we also need to, and so some directions here, if you want to use satellite imagery, for example, is to think about low dimensional satellite imagery. So compressing your satellite imagery, not using maybe more data than you need, and also thinking about data efficient, model efficient, and energy efficient ML, which are all growing areas. If you want to look into that. And some people that are working on that are actually the DARE Institute and some other people across various institutions. And so we also need to avoid, for instance, technical solutionism. ML is not a cure-all. It's only one tool to approach climate justice issues. Moreover, a simple model might actually sometimes perform the same as a deep learning model and actually permit interpretability for stakeholders. For instance, they can understand a linear regression. They know how much error there was, and they know exactly how the model came to get that output. And so sometimes it's okay to, as a data science, just use a simpler model if it gives you the same thing. And so another thing is that qualitative data is also informative. It's not all about the quantitative data. Ethnographic interviews, testimonials from indigenous people and organizations, and youth who are impacted by this, women who are impacted by this, people in underdeveloped nations and stuff like that are also useful insights in addition to the quantitative analysis that we do. And so some of the key takeaways for this are that climate justice is an important issue facing us in the 21st century. Machine learning, deep learning, and data science can provide insights for climate risk management, adaptation, planning to address UN SDG through the lens of climate justice. And it's also important not to view machine learning as the ultimate fight against climate justice. It's only one tool in our toolbox. And we must also respect the autonomy and sovereignty of those we seek to help with climate justice issues. And that concludes my talk. So I guess there's like a short Q&A session, but yeah.
Yeah, thank you very much, Lelia. So first let's unmute yourself and have an applause. Thanks very much. Now, are there any questions from the audience? And you can also chat that, put it in the chat on Zoom. While I can start. So it's very interesting. It's actually, I need to say that really it's not much has been done in terms of climate justice in ML and in statistics as well. But since most of the environmetrics community really at this society are from statistics, so how do you see fusion of statistics and machine learning for addressing climate justice or injustice?
Yeah, I think there's a couple of paths, which is, again, like participatory research. So there's already been some people who have thought about working with local governments in terms of just like, for instance, conservation to inform policy in underdeveloped nations. And so that could be potentially one source of direction to kind of understand climate justice issues, is working directly with indigenous organizations or local and national governments in underdeveloped nations or in underserved communities and things of that nature. So I think that's one direction. Another direction is to kind of figure out, I think one direction that is actually like very straightforward for a lot of people who are already statisticians to work with. A lot of people who are statisticians actually are very knowledgeable in biostatistics. So I think the health disparities and the climate epidemiology is actually something that they could be very like pick up very quickly and do very well at, and quickly understand a lot of things and leverage data sets. And I think we also as a community take a lot of time to curate data sets. So from my vantage point, I think those are some very simple ways for us to approach that. But yeah.
Nasia.
Hi, Lelia. Thank you so much
Hi.
for your talk. I would like to know something related with that. I mean, I'm not sure. Is your research quantitative research or qualitative research, or like a mix of both?
So I do mostly quantitative research. Yeah, mostly quantitative, yeah.
Okay, got it. So have you, I mean, given the current state of your research, have you tried to link what you're doing with some policymakers to actually, make a change in society, given what you are discovering right now in terms of climate justice?
Yeah, the goal right now, my research is still kind of ongoing, my thesis research, but my goal right now is to link it to both policy and economics so that kind of I provide a good understanding to stakeholders of and sometimes the economics is going to be on the softer side. Like this study said that if you improve this, then like if you do more education, then you'll have better outcomes. And then I kind of confirm that with my results. I think some of that is like softer, but yeah, the goal is to always like link back what I'm doing to policy. Like, how does this help policymakers? Who are the stakeholders? Is it people in the Department of Education? Is it a local department? Is it people in, will the EPA find this of interest? Will the NIH find this of interest? Like, who is this of interest to in the national sense? Who's this of interest to like locally in Boston? Who's this of interest to in terms of the UN? So always trying to link it back to like, who is this of interest to? Who are the stakeholders? Who are the impacted parties? Like what indigenous organizations are working on this? And can I have some talks with them about like maybe some like nice directions to go in? So I think that's yeah, I hope that answers your question, but just like always linking it back to policy and just trying to figure out who should this be targeted to and kind of trying to frame it that way a little bit.
Okay, got it. Thank you. Thank you so much, because I was wondering what type of institutions would be interested on this sort of research.
Yeah, for sure.
Thank you so much.
For
Lelia.
sure. Thank
Okay,
you.
thank you very much, Leah.